Good evening to Sir Petrus bin Banati, our course lecturer. We from Group 5 want to present about heat-saving instrument in steam power plant. Introduction of steam power plant. A steam power plant consists of a boiler, steam turbine, and generator and other auxiliaries. The boiler generates steam at high pressure and high temperature. The steam turbine converts the heat energy of steam into mechanical energy. The generator then converts the mechanical energy into electric power. Here are some typical applications for steam in industry. Firstly, heating, propulsion, motive, atomization, cleaning, moisturization, and lastly, humidification. There are two types of steam in steam power plant. That is boiler and turbine. Boiler. There are two basic styles boiler for steam boilers in this range: fire tube and water tube boilers. Fire tube boiler has the fire combustion gases inside the tube, and the water tube boiler has the water inside the tube.
Turbine. Steam turbine comes under the classification of a mechanical machine that isolates thermal energy from the forced steam and converts this into mechanical energy. As the turbine produces rotatory motion, it is most appropriate for the operation of electrical generators. There are two basic types of steam turbine, which are called impulse and reaction turbines. There are other types of steam turbines that are actually derivative of these two main types. The superheated steam is projected at high velocity from fixed nozzle in the casing. When the steam strikes the blades, sometimes called bucket, it causes the turbine shaft to rotate. The high pressure and intermediate pressure stage of a steam turbine is usually impulse the turbine. The steam expands torque the fixed nozzle, where a pressure potential energy is converted to kinetic energy. The high velocity steam from fixed nozzle impacts the blade nozzle, change the direction, and undergoes further expansion. Overview of steam power plant auxiliary system: pump, filters, coolers, centrifuge, turbine governor, steam turbine condenser, air ejector.
The function of the heat-saving instrument is to transfer heat from the one medium to other medium. This media may be a gas, liquid, and combination of both. The medium may be separated by solid wall to prevent mixing, or may be in the direct contact. Heat-saving instrument can improve a system in efficiency by transferring heat from a system where it is not to need to other system where it can be usefully used. Consists of economizer, air preheater, soot blower, and steam trap. First, economizer. Modern day boilers such as those in coal-fired power station are still fit with economizer, which descendants of green original design. In this context, they are often referred to as feed water heaters and heat the condensate from turbines before it pumped to the boiler. Next, air preheater. APH, a shell and tube type heat exchange installed in boilers to heat the air before using it for combustion. The main function of an air preheater is to extract excess heat from the flue gas in the boiler. Function of air preheater in boiler is actually heat exchange located at the next exit of the flue gas duct in the steam boiler. Types of air preheater: tubular type air preheater, regenerative type air preheater.
The use of soot blower. A soot blower is a device for removing the soot that is deposited on the internal furnace tubes of a boiler during combustion to prevent plugging of the gas passes and maintain boiler efficiency. There are four types of soot blower. First is wall blowers, also known as IRS, insertable rotating, long retractable soot blower, brake soot blower, and fixed rotating soot blower. The use of stream trap. A stream trap is an automatic valve that holds the steam at the load until it gives up its energy and condenses the water. After the steam condenses the water, the steam trap allows only the condensate to pass, thereby contributing to plant efficiency. Since steam naturally releases heat, which causes condensation, another use of traps is to keep steam lines free for condensate. If the condensate is not removed, it will cause water hammer, which can cause damage to valve, piping, and equipment. Considerable damage can be costly and eventually require equipment replacement. Although there are many types of steam trap, the three most commonly used are the invented bucket steam trap, the float thermostatic steam trap, and the thermostatic steam trap. In conclusion, we have learned a new knowledge in more depth for the result of this case study. Not only that, we also know each instrument as well as the related functions in the thermal power plant. Next, we also found knowledge that we can bring to further industrial training in the future. So this makes it easier for us to understand on each instrument that is closely related to our topic. Thank you.